Hello guys, in this video we will be looking at how to find mean and variance using probability generating function on binomial distribution. So mean and variance of binomial distribution using probability generating function. Probability generating function. So we'll be deriving the we'll be finding the probability generating function for an event which is equal to 1. That is, we have to find the probability for the success sample errors, success samples. Okay, so that's why we will be taking later I will explain why we need to take the probability for only for a success rates. So let's just try to solve the equation. So it is a probability generating function formula, that is t power x, expectation values of t power x. So p of x is equal to expected value of t power x. So what is binomial distribution formula? P of x is nothing but the ncx p power x q power n minus 1, right? So sigma x is equal to 0 to infinity t power x into ncx p power x q power n minus x. So here t power x p power x. So powers are equal, so we have to merge the bases. Sigma x is equal to 0 to infinity pt whole power x ncx q power n minus x. So we know that if the equation, if the anything in the form of ncx p power x q power n minus x can be written as p plus q whole power n, right? So here pt plus q whole power n, which gives rise to gx of t. So probability the generating function can be represented with the gx of t. So now let us try to find the raw moments. That is mu1 dash is nothing but the first order derivative, that is d of gx of t by dt such that t equal to 1. So in the previous video we have seen that we have taken for the t equal to 0, but coming to the probability generating function we have to take t equal to 1, because we have to make the binomial distribution only for the success elements, success experiments. So that's why we'll be taking t equal to 1. So what's the d by dt of what's the gx of t? That is pt plus q power n. So we have to derive it, so we'll be getting a derivation. So it is x power n, that is n of pt plus q. So q equal to 0, then we will be getting here we will be getting p, so t equal to 1. So what is happening here? So such that t equal to 1, substitute t equal to 1 in the equation, we will be getting np of p plus q. What is p plus q? P plus q is nothing but equal to 1, so we will be get np. So mu1 dash is equal to np. So let us find the variance. So variance is nothing but the double order derivative, that is d square by dt gx of t such that t equal to 1. So d by dt of gx, it is d by dt gx of t such that t equal to 1. So what is d by dt gx of t? It is nothing but np p plus what it is in here we have to take before the submission, right? So this is the equation, that is d by dt of n of p plus q. So here we forgot to write n minus 1, so make a note of it. So n came down, so it should be n minus 1. So np of n minus 1 into p such that t equal to 1. So now we have to, what are the constant terms? np are the constant terms, so get the np outside, np. So d by dt of p plus q power n minus 1. Is it pt, sorry for that, pt plus q power n minus 1 such that t equal to 1. So let me go slow. Okay, np. So what is the differentiation? So let me write this step again. np d by dt of pt plus q power n minus 1 such that t equal to 1. So we have to write, we have to differentiate it. So that is np. So x power n, nothing but the n, that is n minus 1 into x power n minus 2, that is pt plus q power n minus 2 into what is q? Q will be 0 and p, it will be p. Okay, such that t equal to 0. Oh sorry, t equal to 1. Now substitute t equal to 1 in the equation, that is np of n minus 1. What will happen here? We will be getting p plus q power n minus 2 into p. So what we know that p plus q is nothing but the 1. So we will get np of n minus 1 into p. Okay, is nothing but np square of n minus 1. What is this? Mu 2 dash. So let me write here. So now we have to find the variance. Variance, we know that variance is nothing but the mu 2 dash minus mu 1 dash whole square. What is mu 2 dash? Np square of n minus 1 minus what is mu 1 dash? Np. So np whole square. So multiply this inside, n square p square minus np square minus n square p square. What will we get? So we got, we'll be getting cancel this one and this one. So we got np. So you can see that we got minus np square term, that is mu 2 dash. But this is not the actual solution we required. But coming to the probability generating function, so we have to add one more parameter, that is e power x to the mu 2 dash, that is mu 2 dash is equal to minus np square plus np. What is np? Mu 1 dash. So we have to add another step. So another step is there in the probability generating function. So here we will be getting our final step. So exam we also write the so these are the 4 steps we have to involve. So let's take out the np common. If we take np, it is 1 plus, sorry, it is 1 minus p. So it will be 1 minus p. What is 1 minus p? Is nothing but the q. It is np q. So mu 2 dash is equal to npq. So this is the actual process to find the mean and variance of probability generating functions. So let me wind up everything what we have learned so far. So just be careful by doing probability generating function. We have to take t equal to 1, as well as there is another step in the probability generating function, that we have to add the e of x value again. Okay, is it clear? So now let us coming to the problem. P of x is equal to e power t power x is a probability generating function. So now we have to multiply with the binomial distribution function, that is ncx p power x q power n minus 1. Then we have to solve this. Then we will be getting a gx of t is equal to pt plus q power n. So now let us find the raw moments, that is mean. So mean is equal to first order derivative of probability generating function, d by dt of gx of t such that t equal to 1. So why we have taken t is equal to 1? Because t is called 1 is for the success experiments. Sorry. So d by dt of pt plus q power n. When we have solved all this thing by substituting t is equal to 1, we will be getting a solution of mu is equal to np. So it is fine. So let us solve for the variance. Variance is nothing but double order derivative of probability generating functions. So gx of t such that t equal to 1. So d by dt. So by solving it, we will be getting a, so it is pt plus q, it is pt plus q power n minus 1. This is one. So you can eliminate this, comment this. So np of d by dt of pt plus q power n minus 1 such that t equal to 1. So now substitute t equal to 1, we will be getting a p plus q power n minus 2 into p. What is p plus q? P plus q is nothing but the 1. So np of n minus 1 into p. Mu 1 dash is mu 2 dash is equal to np square minus n minus 1. So in exam you can directly solve it by using by adding another mu 1 dash, or if you don't want, you can directly make it 2 statements. That is, we have followed till now we have followed this process, right? So if you want to take another step, do it like this, or if you want to wind up in the one statement itself, so plus add mu 1 dash here itself, then plus np plus np. So you can do it like this, or if you get confused by doing this, so try to make a different one by adding np with the np to the mu 2 dash. Okay, so then we'll be getting a mu 2 dash. Here we got as np minus np square, plus we have to add the e of x value, that is mu 1 dash value here. Then we will be getting our required solution, that is npq. Hope you understood this video. Everything is clear, I think so. Thank you.